I made a huge mistake. I thought this was a conference about Star Trek, so I wore a Star Trek t-shirt. Turns out it's a conference about enterprise technology, not the enterprise. I want to be, I feel extremely honored to be here. I'm really glad that I can be the very first person to welcome you to Philadelphia Emerging Technology for the Enterprise. Thank you. It's an honor to be the first speaker. Actually, no, I'm really excited to be here. The keynote this morning was amazing. Claudia gave an excellent talk about numbers and online advertising, and I actually used to be in the online advertising business, and we thought the entire secret was doing Fibonacci sequence crunching, and it turns out that is not true. So I guess that's why I was never successful in online advertising. Oh, right. For those of you who don't know me, my name is Eric Patterson. I go by Tenderlove on the internet. You can find me at that name, typically. It's probably easier to Google than Aaron Patterson. For those of you who don't know me, I'm on the Rails core team. I am also on the Ruby core team, but people most know me for the enterprise gem. You can go check this out. Basically, if you're at an enterprise company like I am, you can really only run XML in production. So what we do with this gem is we convert all of our Ruby code into XML and then deploy that, and then in production it gets turned from XML back into Ruby and runs. So it's totally enterprise. Go check that out. I work at AT&T. They employ me to do open source software full time, so I'm just an open source coder all day. People are surprised when I tell them that. I work for this giant company and they let me do open source stuff. And I'm here to tell you that AT&T isn't nearly as bureaucratic as you might think it is. I mean, it's a huge company, but we're not nearly as bureaucratic as you might think. And if you don't believe me, you can send me an email. That's my email address. No, really, that's my email address. And actually, unfortunately, I can't respond to you because I'll get your email, but I can't respond because I can only send email to other people to AT&T addresses from that address. So it's pretty amazing. Anyway, speaking of email addresses, I want to cover a little bit about my expense reports, and then we'll get into some hardcore nerd stuff. So the way I do expense reports is like this. That's me. We use Concur, and the way that it typically works is Concur requires that we send in a fax. So we have to fax all of our receipts in, and then when Concur receives it, it converts the faxes into a PDF. So the way that we do it is, I don't have a fax machine, is I make a PDF, I send an email, the email goes to a fax machine, the fax machine sends the fax, it gets turned back into a PDF, and then goes into Concur like this. But for about a month, I wasn't able to access my email because it just got shut off for some reason. This is what happens at enterprise companies. I'm sure all of you know this because we're here at an enterprise conference. Your email just stops working for some reason. I checked, I was still getting paychecks, so I didn't really care that much, but whatever. So what ended up happening was, I'm like, okay, I got to do PDF. I sent an email, but I had to send that to my boss via Gmail. My boss then goes around and sends an email, and then that gets sent to a fax, and that goes to PDF, and then that goes to Concur. And I think it's pretty amazing. It's really awesome. You can go into Concur and check your PDF, make sure that it turned out right. And I think there's other steps in this graph. These are just the steps I could figure out. The reason I can tell there's other steps is because when I go check out the PDF, I can see that there's all these, please consider the environment before printing attached to it. And I'm like, I don't know where that came from, but it came from somewhere. I don't know. So I like to call this the Rube Goldberg expense reporting system. And actually, you may think that's a funny name, but AT&T, we actually hired Rube Goldberg to design this expense reporting system, so that's why it's called that. That's the real name. Well, so I'm trashing on our expense reporting system, but it's actually kind of amazing if you think about it in terms of interfaces and adapters. Because before, someday, we had to send faxes. People were actually required to send these faxes into the system, right? And then along one day, somebody said, look, I can't send a fax. I don't have a fax machine. Why can't we just use email? And there was probably a meeting somewhere in Atlanta or something, who knows. A bunch of developers get together and they're like, okay, we need to send somehow get faxes into the system or somehow get these receipts into the system, but we can't change the existing system, so how can we do this? And you know that there was one developer there who was like, guys, I've got a brilliant idea. I've got a brilliant idea. We're going to take that email, and we're going to send a fax through the email. And everybody else is like, no, that's ridiculous. That's an incredibly stupid idea. And then that developer just let it sit there just for a minute. Just for a minute, and then everybody else is like, you know what? That might actually work. Let's do this. And then that's how it happens. So I just want to be a fly on the wall at one of these meetings. It would be amazing. Amazing. A fax that goes to a PDF that goes to a fax back to a PDF. Awesome. Anyway, so, all right, let's talk about some nerd stuff, I think. The title of this talk was Exploring the Internals of Active Record, but I have an hour. And I thought it would be pretty boring to talk about that for an hour. So I'm also going to talk about new things in Rails 4. And I'm also going to talk about some pictures of my cats, but I'm gonna front load that operation. So I'm going to talk about first do cats, my side gig, then Rails 4, then Active Record internals. So this is my cat. He only speaks Japanese for some reason. I don't know. He yawns a lot, all the time. All the time. So I love my cat. But I realize that not everybody does. His name is Gorbachev. So my cat's name is Gorbachev Puff Puff Thunderhorse. And the reason his name is Gorbachev is because we bought him from he was a stud cat, a former stud cat, used for breeding. And we bought him from a Russian breeder, and she was Russian, and she told us his name, but we got it in the car with him, and I'm like, I can't remember. I really can't remember. So we had to choose between Piroshki and Gorbachev, and I'm like, okay, Gorbachev, that's it. Anyway, so I love my cat a lot, and I realize not everybody does, but I didn't realize this until recently because my coworker got this email. And the email was just from somebody who said like, I saw your talk about creating open source projects, and his name is Ryan, my coworker's name. And I saw your talk about creating open source projects, and I saw Aaron Patterson's talk about it, and both of them are really inspiring to me. I'm really excited about it. I want to learn more about making open source, and I want to become a good Ruby programmer. And then, et cetera, et cetera. And then at the end of the email, he says, the reason I'm contacting you instead of Aaron is because I don't want to hear about his cat. I don't want to hear about his cat. I'm interested in mastering Ruby. And so Ryan forwarded this email to me, and I almost died laughing because Ryan complains every day. It's like, why do you talk about your cat so much? Why do you talk about your cat so much? So I was just dying reading this. Anyway, yes. So I wanted to tweet about it, but I didn't want to embarrass the guy, so I'm just telling you guys here. So I figure it's anonymous enough, but I really appreciated this email. It made me laugh, which is why I front-loaded all the cat pictures. There will be no more cat pictures. But if you do like my cat, I got stickers of him, so just come say hello and I'll give you one. So I spoke at ETE last year, and I want to cover what I did over the previous year, what I've been up to for a year. And the first thing is I got married. That's pretty exciting. Thank you. Yes. I like being married. No jokes about it. It's great. And the other thing that I did is I started a side business. Where's the mic? Durr, 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 dun, 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 dun. This is my side business. I was going to put the music in from 2001, but I figured just singing it would be good enough, be adequate. So this is the name of my consulting company, and I want to talk a little bit about my consulting company. This is our motto. You get what you think you paid for. I'm actually really happy to be here and talk to enterprise people at an enterprise conference, because a lot of the times I go to other conferences, and it's all mostly startup people who want to disrupt spaces. They want to disrupt space. We're disrupting it, whatever. We're disrupting breakfast cereals. It's amazing. So what we're doing at Adequate is we're actually going to disrupt the space of space disruption. I figure that's like a new thing to get into here at ETE. So the other thing that we do at Adequate is SEO optimization. And you're not reading this incorrectly. We do search engine optimization. That's what we do. And in order to talk about search engine optimization, I need to show you a picture of the first search engine. This is the first search engine. It was steam-powered. The first search engine was invented in 1574, or 1547. It was invented in Holland and came to the United States along with Leif Erikson. Went up there like that. Pretty amazing. Holland is down there. Yes. So in the United States, we improved the search engine, made it gas-powered. Oh, I don't know if you know this. Leif Erikson, he later went on to invent cell phones. Erikson Cell Phone Company, you may have heard of that. That was from him. Anyway, so you can tell from modern search engine names that they, like all these modern search engines, they harken back to the original like gas-powered search engines of yesteryear. For example, Google is the number of cylinders in their search engine. Yahoo is the sound the exhaust system for the search engine makes. And Bing is the sound of a broken engine. So early search engine optimizers found out that by shouting certain words at the machine, they could get it to work better. So they would shout, you know, faster, better, stronger, and it would go, like the search engine would actually work better. And then actually a guy named Alexander Search Keyword came along and found that if we shouted certain keywords at it, we could get the right data to come back. We could get the right websites to come out of the search engine there. So he was the first one that invented search engine optimization, and so that's one of the things that we offer at Adequate Industries. And like I do client work for people, and basically what that involves is me like shouting at the computer. Looks like that. I'm doing some client work there. Also, I have recruiterspam.com. You should go check that out. So now for some nerd stuff. Rails 4. Rails 4. Okay, so I've got the release date. Release date is September 2012. Obviously, this date has passed. So I'm going to talk about some of the things that are in Rails 4 and go into some details of just some stuff about it, and then hopefully we'll have time for questions later. The first thing I want to talk about is Rails queue. So we've got a queue in there. Rails.queue. And the way it works is it's pretty easy. We just have a job. You put the job onto the queue, and then we can pop stuff off of the queue. So we have an example here. Here's an example consumer. We just pop a job off the queue, run the job, and then we go. So this is great. We were messing with this. But then we ran into some problems. Like I was speaking about this. People came to talk to me, and we ran into problems. And people would ask, well, you know, what do you do about exceptions? What do you do when there's an exception in your job? And you think about that for a little bit, and you're like, well, you know, it really depends. I mean, it's queue specific if you think about it. Like, for example, this one that I showed you on the slides, it's an in-memory queue, and if like your process dies or the thread dies or something like that happens, like, what do? In this simple example, well, you lose your job. So maybe you want to choose a particular queue that has resiliency along with the jobs. So, okay, maybe pick like RabbitMQ, for example. 0MQ has transactional messages, so you can keep track of that stuff. So even if your processes or boxes go down, you're fine. In-memory queue has different requirements. So then people would ask, well, what about serialization? Okay, how do you get the jobs into the queue? And then I'm thinking about that, and like, well, okay, I guess that's also queue specific. Because if you have an in-memory queue, well, you just push the job on. There's no serialization. It just goes in there. But you know, if you have something that needs to go over the network, what do you do? So, well, it depends on your queue again. And then somebody says, well, what about job construction? Like, how do you construct jobs that actually go onto the queue? And I think, well, okay, let's make a minimum requirement. The minimum requirement is that the job has to be marshallable, so that at least we can have marshal serialization push the job over the wire if we need to, right? So we think, okay, great. Got all these questions answered. Well, okay, let's do some job construction. We find a user, put that user into a job, and then queue that job up. Simple as that. No, unfortunately not. It is not that simple. And the reason is because that user was actually an active record object, and that active record object might be holding on to things like, for example, a database connection. So really what we need to do is we need to have something like this. This is like, okay, instead of adding the user to the job, we add the user ID to the job, and then we push that onto the queue. Okay, so we do that. And then if we look at, well, the job definition itself, we actually store the user ID, and then we have to go look it up every time. We have to do this on every single job, store IDs, and go look these things up later in the database. So really what happened is there are too many questions, too many open questions, talked about it too much, and well, it went away. So we removed that from 4.0. Don't lose hope though, it's still up there. We're probably just gonna push it to 4.1. So, oh, by the way, like, if any of you want to do some open source stuff, this issue of job definition that I talked about, storing the IDs, I think we could abstract that away to a superclass that would look something like this. So think about that for a minute and maybe send a pull request. Next thing I want to talk about is minitest spec. Minitest spec looks like this. So you write some tests, it looks like specs. How many of you have used RSpec? Okay, great, awesome, all of you basically. So here's minitest spec. It looks very similar to RSpec, but it is not. It's not RSpec at all. It's minitest. Think about it as like RSpec light, basically. So what's interesting is if we look at Rails tests, so here's an existing Rails test. You can write this in Rails today. Excuse me, we have a setup block, and then we have a test block. Now let's look at minitest spec. Well, it looks extremely similar. We have a setup block, and we have an it block. And well, if you think about it, well, let's just take, we can refactor a little bit and say, okay, let's alias test over to it. And now we don't have to say it, we can just say test. And now if we refactor that into a superclass, now our sum test is implemented by minitest spec, and it actually implements exactly the same interface as Rails' tests. So with these three lines here, we can remove all of the DSL support from Rails and actually push that up into minitest spec. And what's really cool is it's completely backwards compatible with test unit. And I can actually prove this by looking at the ancestors of minitest spec. You can see it goes back up to test case there. So it's completely 100% backwards compatible, and yet you get free goodies out of it, like doing this DSL type stuff that looks similar to RSpec. But unfortunately, it got removed. And the reason it got removed is because somebody talked. That would be me, unfortunately. My loose lips sank ships. And it turns out that not everybody likes the aesthetic of spec style stuff, even though they don't know that it's been in Rails for 6 months. So somebody did not like the aesthetic and removed it, so we don't get that. So I found a pattern to this, and what I found out, like, I kept putting the stuff into Rails, and I found out it was getting removed, and I figured out the pattern. There's a pattern. The pattern is, as soon as I give a talk about something, it gets deleted. This is the pattern, okay? So I came up with a plan. This is my plan. I'm going to share with all of you my plan. Came up with a plan. We're going to talk about turbo links. I'm kidding. We're not going to talk about turbo links. Actually, I want to talk to you guys about real stuff that's not actually deleted yet. We're going to talk about streaming. So we're going to take a look at Action Controller Live. This is a module that's in Rails 4 that you can mix into your controllers and get a live stream that goes out to the client. So here's an example of using Action Controller Live. You mix it into your controller, and you get this stream on your response object, and you can write to it, and that actually goes out to the client, and we can see that running. So here I got a little example of it going here. Write some stuff out. I've got the server running in the background. Do a curl on that, and we'll see, like, okay, we actually get data written out to the socket live, which is different from the way Rails works. Rails 3.2 works today in that everything is buffered before it's written out to the socket. So with this module, you don't have to buffer anymore. You can just start writing stuff to the socket. And the cool things that you can do with this are we can refactor ERB such that it's streaming. So it'll be possible to redo our templating engine such that your HTML templates could possibly be streamed out to the client as soon as they're calculated, rather than the way it is today, which is they're all stored in memory and then spit out to the client. We can have infinite stream APIs similar to Twitter's tweet API, or we can also do server-sent events, which I want to talk about server-sent events because that's actually my favorite feature to use this with. So this is what a server-sent event looks like. It's a special response, just a normal HTTP response, but we add this extra content type header here. And then we have these little chunks of data that look basically like JSON. We have little events here, and they can have a name, like this one is named ping, and it has a little, right down here, it's got a payload there that's sent to the client. And every time the browser receives one of these payloads, it executes a JavaScript callback. So you can register to listen for these things. The browser will open a socket to the server and just sit there and listen, and every time it gets an event, it executes this callback that you define. So I want to show an example of using it. Here we have, this is a sample application. Here we've got just some users, and that's cool. We can see the server is running, great. I go in here and modify some stuff, and as soon as I modify the file, you can see it just automatically reloads here. Yay, amazing. It's awesome. I actually really like this because I'm a horrible, horrible web designer. So as you can see here, I'm going to demonstrate. This is my CSS file. Watch that green, that beautiful green. It's amazing. Yeah, and then the other thing that I want to demonstrate with this is like, okay, well, we're going to connect to the console here. We'll fire up console and say, okay, I'm going to create a user, and notice that the console is in a completely different process, and it shows up in the web server over there. The web browser automatically reloads, and we actually get data pushed up to the client. And we're doing that all completely with server-sent events. The way that it's built is we have a web server here with file system events. The file system events let the controller know, hey, it's time to push out a new event. That goes to the browser automatically reloads the page. And we can define whatever the browser does. I just wrote it to just do a stupid simple reload, but you can make it more complex, do anything you want. And the way that the database events work is the console actually connects over a socket via DRB, and then we have a DRB process running inside of the web server that communicates back up to the browser, hey, it's time to reload. So the arrows are a DRB server, SSE implementation, and a few JavaScript components. That's what actually strings all those things together. And the other interesting thing about using server-sent events is that we can use them for streaming or polling. So you saw that event there, or that example was using an infinite stream. But what you can do is you can actually say in the server-sent event, that payload, you can send along a timeout. So you can say like, okay, if the server disconnects, then I want you to reload this source every n seconds, right? So what you can do on the server side is you can say, okay, here's your payload. I want you to reload in 3 seconds, and then just close the socket. And then the browser will automatically say, oh man, the socket closed. I'm going to go fetch this after 3 seconds. So you have an automatic polling system built into this. So you can use it for streaming or polling, whichever you want to use for your system. So pitfalls with this technology are, well, it depends on the web server. You need to use the right web server. Some web servers actually buffer the entire response. For example, WebRick will buffer the entire response out of the box, so that is not fun. You need to choose the right web server. And then the other problem is that you need to choose whether you want threaded or multi-process web servers, because this is going to tie up a socket, right? You have an infinite stream open there, which means that if you're running a multi-process-based server, you're completely tying up the process for that amount of time. Maybe you want to use a multi-threaded server so that you can handle more concurrent requests. So the other thing is that you have longer responses. Obviously, if you're doing an infinite response, then your response time is infinite. So, but I mean, really, like, this is why we're putting efforts into Rails to make it work with threaded web servers and make it thread safe so that you can run threaded web servers and handle as many concurrent requests as you want to. The other thing that's kind of annoying to deal with is client disconnects. So if, say, somebody connects to your website and then they just close their laptop, right? How do you tell on the server side? How do you tell that they disconnected? It turns out it's actually really annoying to tell whether or not they disconnected. There's certain things that you can ask the socket that maybe you can get kind of an idea about it, but really the only way to know for sure is to actually just write to the socket and have it fail. That's the only way to know for sure. So what we've been doing, like work that I've been doing with this stuff, I end up using something like this a lot where I'm sending a ping. Basically, I'm sending a packet to the response in a background thread just saying, hey, let's ping that socket every once in a while, see if it's open, and if we get an exception from that, then we know, oh, the client has disconnected, right? If you don't want to do that, then you can switch, use polling. So the next thing I want to talk about in Rails 4 is faster tests. We got faster tests. Note, they are not actually faster. And I will explain to you why. It looks like they are faster, but they are not. So let's do this. All right, here's Rails 3.2. Very simple. There's a very simple application we have here. You run a time on Rake test. I snipped out a bunch of output stuff. And we see here, OK, it took about 4.7 seconds to run the entire test. OK. 4.0 beta, same application. It took 1.9 seconds to run all the tests. So wow. Wow. So much faster. Look at these graphs. Amazing. Beautiful. Yeah. Man, look at that speed. So, OK. I'm sorry, they're not actually faster. What you see here is an illusion. And I'm going to explain the illusion to you. It's real but fake at the same time. So the way that we speed these up, as well, let's look at where is the bottleneck. So how do we, where is the bottleneck in your application? Turns out if we break down the time, do a time breakdown of this, right? Let's run one test. We'll run one test. This application actually only has one test in it. We run one test and we see it takes about 1.7 seconds, which you'll notice was almost exactly the same amount of time it took to run in Rails 4. Look at that, 3.2, 1.7 seconds to run this one functional test. Rails 4.0, exact same amount of time to run that functional test, right? So the test didn't actually get any faster. Exactly the same speed. The problem is, where are we spending our time? Jim, I'm glad you're here. So I'm going to talk about you, some of these slides. Where are we spending our time? It turns out that we're spending our time loading the application. If you go profile Rails startup, it's really loading files, doing file loading, and compilation of the Ruby code. That's the slow part. And if you run this, make a mental note of this, or I'll post the slides, but you might want to run this in your Rails application. All this does, this literally just loads your application and does a no-op and exits. So you can see how long it takes to just load your application and do nothing. So just loading this basic application and doing nothing takes 1.4 seconds. And you'll notice our test time was only 1.7 seconds. So obviously, the giant part of running these tests is just loading the application. So, all right, we know this. Tests take about 1.7 seconds. Loading the application takes about 1.4 seconds. So what is the deal with Rails 3.2? Why is it so much slower? Well, let's think about how do the tests work? How does the test, cool English, Aaron. Here's a sample test task. Let's look at the sample test task. This is our extreme sample thing, right? It's just a normal test task, not in Rails or anything. Okay, so here we go. And if you go ahead and you drop this in a Rake file and you go ahead and run it, you'll see output that looks similar to this. And you'll see right here, you don't need to read this. Right there, we're actually running Ruby right there. So when you think about this for a little bit. When you run Rake test, it actually runs Ruby twice. You run Ruby once to load up the Rake file, and then you run Ruby a second time to actually run your tests. So every Rake test loads Ruby twice. Now, if you think about this in terms of Rake plus Rails, well, your application has custom Rake tasks under lib tasks ***, everything under there. We have to be able to figure that out, go load your Rake tasks in. So what happens is we actually load your application in to load the Rake file, to go load those Rake tasks. Then we shell out again and actually have to load your application again, second time. So that's 2 times loading your application. So we can see this here, Rake test unit, you run that on the command line, it loads your Rake file, it shells out, that runs Ruby on your tests. So right here, go transition, go. Right there, we load your application, and then we load your application a second time there. And that's just running the units. That's just running the unit tests. So Rake test units, 2 times app load. If you run Rake test, we have integration tests, unit tests, and functional tests, which means we're loading your application 4 times, right? So we can see, like, okay, it's going to take at least 4x your app load time in order to run those tests. The issue was multiple loads, and we wanted to get rid of that in order to speed up these tests. So the way we can do that is we can say, like, well, let's just require the files. We'll have a test task. All that does is require the files. Boom, done. We've loaded your application, required the files, and then on exit, all your tests execute. So there's a few challenges with this, which I'm going to cover. And these things are extremely difficult, and there is some extremely hacky code to deal with this, which I hope to deal with later. And the problem is switching environments. Unfortunately, your Rails application is a singleton. If you go look at this, this is actually some insane code. My WTF meter broke looking at this code. If you go look at your application, you'll see in config application RB, you'll see your name, your application name, and it's like, okay, my app less than Rails application, right? On that line, that is the line where your application gets instantiated, okay? So in Rails, there is an inherited hook that says, like, okay, go make a singleton of this. You would have a normal Ruby programmer would have no idea. You're looking at this line, oh, it looks like inheritance. Nope, it's actually instantiating your app. Sorry. So what we have to do is we have to switch into the test environment, right? The problem is when somebody runs Rake, what environment are they executing in? If they haven't specified a particular environment, we don't know, so we just default it to development. So terrible. So what we're doing is we're changing the application we're changing the environment before we actually load your application. We can take a look at the task that you're running and say, like, well, it looks like they're running a test task, so let's switch the environment to test before we actually load the application. Then we can load your application in the test environment and go ahead and run your tests. The only problem with that is, you think about this for a little bit. For example, you have this error. I'm sure many of you have seen this error. You forget to run your migrations. You run Rake test, you forgot to run the migration, and it complains to you, hey, you forgot to run this migration. Well, how does it know what database to connect to check to see that your migrations are run? You have to connect to the development database, which requires your application to be in development mode. So the test mode has dependencies on the development mode. So we have to juggle that. These are one of the challenges. We also have to load your schema.rb. And the real solution to all of this is, right now we just have some code that introspects into the task you're executing and changes the environment. The real solution, in my opinion, is to remove the singleton. There's no reason that your application has to be a singleton. I don't understand why we have that requirement. I mean, I guess theoretically people could make multiple instances of their application, but who cares if they do? I don't understand why we have this requirement, so we're just going to remove it. Unfortunately, I think it's a dangerous change, so we're postponing this until 4.1. So we'll fix the test speed in 4.0, 4.1, we'll remove the singleton and actually get rid of the hacks. Now let's talk about active record internals. Finally, this is what you all came here to see, right? Active record internals. We're going to talk about connection pooling, thread safety, SQL construction, and statement caching. Ow! Exciting, exciting. The reason I kind of want to talk about this stuff is, well, twofold really, speed improvements and thread safety concerns. So I think we're moving more and more into a space where we need to have good threaded applications. Like, we need to be running Rails on threaded web servers. This is actually important. Honestly, so before I was a Rails developer, I was a J2EE developer, and I only feel comfortable admitting that because we're at an enterprise conference. And we ran our applications on threaded servers for years. I don't understand, like, why now is the... Anyway, yes. So threaded servers are important. Let's talk about connection pooling. You have a connection pool. This is what your configuration looks like. There is the pool size. We limit your pool size to about 5. That's the default. You can change it. So if you're on a threaded server, you just bump up the pool size. And typically, I recommend that your pool limit is about the same number of threads as your web server, so that each application thread can actually check out a connection from the database. Though, as I'll explain later, you don't need the pool limit to actually equal the number of threads. But we'll talk about that in a bit. So the way that the request process happens is we say, like, at some point in your application, the request comes in, and at some point in your application, you access the database connection. And then you just do some stuff, your normal application stuff, and then we send a response, and then Rails automatically checks that connection back into the pool for you, right? So at the end of the response, we go ahead and say, oh, they checked out a connection, let's put that thing back in. But we don't actually check the connection out from the pool until you call active record-based connection or until you actually access the database. So we lazily check it out from the pool, which means that theoretically you can have more server threads than your pool size is because it's lazily done. This will just block until there's a connection available. So the way you can check it in manually is via this module. There's an active record, or no, I'm sorry, this is the automatic check-in. There's a middleware called connection management. So if you go look through the active record code base, you'll find this as a middleware that just goes and checks in the connection for you. So actually, it's okay to have, it's really fine to have more threads than your pool size. That's actually just fine. But now you know what the semantics are. It'll actually just block until it gets a connection available from the pool. Or you can do a manual checkout. This is what the checkout looks like. You can say, like, okay, I want to check out something. You ask the connection handler, it returns a connection for you, and then later you have to go manually check it back in. If you check something out manually, you must check that thing in manually, otherwise you'll leak connections in the pool. The other thing I want to talk about, which is important, but I don't think many people know about these configuration settings, is the dead connection timeout and the reaping frequency. So the problem is, like, let's say you are running a threaded web server, and one of your threads dies. Just completely dies, drops on the ground, something happens, we don't know. But it checked out a database connection. How does that database connection get put back in the pool? Like, how do we deal with that? We actually have a reaper that sits there and says, okay, well, if the connection was checked out, the dead connection timeout is, if the connection has been checked out of the pool for n seconds, this would be 5 seconds, then we're going to go ahead and see if the connection is alive. Are they actually using the connection? So if they're not actually using the connection, then we're going to close it off and put it back in the pool. But if they are, then we'll just leave it alone. Now this reaping frequency, that's how often the reaper actually goes through and checks your connection pool. So in this case, every 10 seconds, the reaper will check your connection pool for connections that have been open for greater than 5 seconds. So if you're running threaded web servers, you probably want to check out these configuration values. These are not generated by default when you generate an application. So we'll do thread safety. Let's talk about thread safety a little bit. And thread safety is, like, this is one of my pet peeves. Somebody says to me, is XXX library, is Rails thread safe? So to me, is Rails thread safe? And I hate it when people ask this question. So you ask 10 developers, what does thread safe mean? And you're going to get 11 different answers, right? When you say is something thread safe, what you're really asking is, does this library have a threading policy? Because it's perfectly acceptable for you to have an object that is not thread safe. You're not supposed to share that object between threads. Like, that's the policy of the object. You just don't share it. So what you really need to ask is, well, what are your rules? Like, what are your rules for this? The reason this bugs me is, like, basically all code, unless you've got some crazy global variables, we do not have those. All code is basically thread safe if you know the rules. If you know the rules of the code, if you know the rules of the road, you can deal with these thread safety issues. Like, this is up to you. So in order to tell you a little bit about the Rails thread safety rules, first, the database connections are not thread safe. They're absolutely not thread safe. You're not supposed to share these between threads. I will say Rails is thread safe. Rails is absolutely thread safe. Just don't share database connections between threads. The reason these aren't thread safe is because we don't have any locks around the socket. So if you write to the socket, you can't do concurrent writes to the socket. It's not going to work. There's no locks around socket operations. So if you do something like this and say like, oh, okay, go execute some SQL on the same connection in parallel, stuff is going to blow up. You're going to get a race condition, for sure. So don't share connections. The next thing is that active record objects are not thread safe. And I have to say this with a little bit of caveat here, is that, well, the objects are thread safe. It's true that they're thread safe, but the reader and writer methods don't have locks around them, so if you share them among threads and you read and write at the same time, you could get race conditions. We're backing that. Active record is backed, each active record object is backed under the hood with a hash, and we don't do any locks around reading and writing to the hash. So everything will probably work out just fine on MRI because of the GIL, but if you run something like this in JRuby, you're probably going to get a race condition and it'll blow up. Saying like, man, you concurrently modified a hash. What is your problem? Don't do that. So the underlying data structure is a hash with no locks. So, okay, Aaron, you've said all this stuff. You say Rails is thread safe, yet now you're saying it's not thread safe. How do I parallelize? Parallella, Ella, A. How do we parallelize? So the way that we do it at work is we split up our work by type, right? So here's a very short example. We have a queue. We have queues of things that we need to do. So if we need to read from the database, we have a queue for reading from the database. If we need to write to the database, we have a queue for writing to the database. And we communicate through these threads via queues. We say, okay, well, I need to actually do some updates. We'll send that somewhere else. So you can get parallelization out of this. It's just that you need to know what the threading policy is for each of these components. Crap, I was going to finish in 45 minutes. I have a lot of slides. Let's do this quickly. All right, SQL construction. I'm excited about this. Everybody's done this, right? Post.where.where.where.where. 10 wheres. So how does this work? All right, the way this works under the hood. You call .where, we return this object called an active record relation. Then you call .where again, and you're calling it on that active record relation. You get a new one that points back to the old one, and so on and so forth. So these active record relation objects actually hold information about your query. So all those values that you pass to where in any of those builder methods, we hold values about that, and that linked list just points to all of those values. Okay? So then as soon as you call some method like first or each or 2a or anything like that, then we have this builder object called arrow. This is arrow. It goes in and it grabs all the data from each of your active record relation objects, and you can go find this code in AR active record predicate builder. This is the class that you're interested in if you want to hack on this. And then this builder goes around and converts it into SQL and then sends that to the database, and you can go find that in the 2a methods. The 2a method, which gets passed, the SQL gets passed to execute. So you can find the conversion there. So that's how your chained together methods get converted into SQL statements. Now we keep a statement cache, and really we have two caches. When I'm talking about statement caches, in Active Record we actually have two caches. One is a query cache and one is actually a statement cache. So the query cache, the rules for the query cache are if you execute the same statement, you get the same results. So if you do this, find the same find like 10 times in the same request, then we only query the database once and return to you the same values. There are certain things that will blow that cache out, but this is the basic operation of the cache. Now the other one that I want to talk about is the statement cache, and this one's actually more exciting to me than the previous one. The statement cache is when you do something like this, you say like, okay, where, find by some ID, and we'll generate a prepared statement on certain databases. So we'll do this where, and ID equals 1. This is a Postgres one. So the way that the statement cache works is we generate the SQL, we send the SQL to the database server, say, okay, prepare this. The database server plans out a query plan, gets a query plan, figures out, gives you back a token, and then you just go ahead and send that token. So every time you want to execute that statement, you send the token. And this saves parse time, so it's already parsed your statement because you're just sending a token. Saves planning time, saves bandwidth, except on MySQL. But we're at an enterprise conference, right? Nobody uses MySQL in the enterprise. I'm just kidding. MySQL is great. Actually, I shouldn't be talking bad stuff about MySQL. Isn't Postgres going to be releasing some crazy exploit thing or something like that? Anyway, so downsides to this are increased memory. So we're caching all of this stuff in memory. We've got this SQL cache in memory, but we can set a cache size limit. So we'll only cache a certain number of those. That's another database parameter that you can set. Say okay, limit the number of statements you cache. In 4.1, we're going to add an LRU. Right now, it's really a stupid thing that's okay, the last statement, just throw it away if we reach the top. But really, we need to be calculating an LRU for this. So if somebody wants to write that, that would be great. Anyway, so you do this, you're doing this, you're writing this code in your controller, right? And it's great. You're querying the database. The only problem is, every time this code gets executed, we're creating all of these objects. This entire object chain is being allocated every single time. Every single time. And the thing that sucks about it is, well, basically down here, these three down here, only that x value, maybe only that x value is the only one that changes. Every other time you execute this code, you end up with exactly the same results. Every one of those objects has exactly the same internal state, except maybe x, which was a value that was passed in from the parameters. So why are we generating all of these objects? So what I want to do is I want to be able to cache all of these invariants. What I want to do in Rails 4.1 is say something like this. Okay, when you call post.where.where.where.where.find, what we're going to do is we're going to take and execute that entire thing once, calculate the SQL statement for that, and then next time you execute it, rather than calculating all of those objects, all we're going to do is take that cached one and change the bind values. So you declare in advance, you say okay, these are my variants. This is the variant of my particular query. This is what's going to change each time we execute it. And then we can actually do something intelligent and say okay, we know that that's the only bit of data that's going to change between these particular queries, so we're not going to execute all of these values over and over and over again. So this is something that we're working on in Rails 4.1. I've got some students from Helsinki working on this. It's pretty exciting. Although I think their souls are almost crushed by Rails internals. I haven't quite broken them yet. So okay, all right. I want to end with one thing here, one story to end this, and then we'll do some questions. Hopefully, I want to talk about Mamba Time. I've been trying to lose weight. This is my weight graph. I've lost weight. See, it's going down there. And I hate working out a lot. Physical activity sucks. I do not like it. But I want to make sure that I'm staying healthy or whatever. So I go on walks. I go on health walks. I call them health walks to try and motivate myself. Yes, I'm staying healthy. So I walk around my neighborhood, and there's a 7-Eleven I go to, right? Because I'm walking sucks, I need a reward. So I go in there and I love gummy bears. Candy is so good, love it. So I go in and I'm looking at the candy section in 7-Eleven, and I see they have these ones. I'm also a sucker for anything new. Any new flavors of Doritos, I'm boom, on it. Give me that. Those Cool Ranch taco Doritos, those are the best, I love them. So anyway, I'm looking at the candy aisle and I see these ones called Mamba gummies, Mamba Time gummies. And I'm okay, sweet. I'm going to buy these. They're brand new. So I go buy them. Great. Next day, I do my health walk. And I'm you know what? I need another pack. Go in and buy some. Okay, so a few days later, and I'm doing these walks every single day. A few days later, I go in and I buy another one. And the guy at 7-Eleven, he's hey, Mamba Time. And I'm oh, man. Well, I guess I can't come here anymore. So I'm okay. So I'm all right, well, that's fine. I walk around the neighborhood again. I'm well, just go to the grocery store. I'm sure they have it. Go to the grocery store, they don't have it. Okay, well, I'll try a different grocery store. That grocery store doesn't have it either. And I'm well, I can't find it at any of the grocery stores in my neighborhood. And I'm but I walk by the 7-Eleven every day. So, obviously there's got to be a day when he's not working. There's got to be a day he's not there. And I can go in and buy them. No. He works there every single day. Every day. Every day. And like, I realized, you know, well, this guy, like everybody who goes into the 7-Eleven, it's always somebody who's buying like, you know, booze, cigarettes, dirty magazines, something like that. I'm the weird one. I'm the strange guy going in there buying candy. Apparently, I'm the only one that buys candy in this place. And he remembers that, like he remembers me, so I'm like, you know what, screw it. I go in, get my Mambas, give it to him, and he's like, hey, Mamba Time, and I'm like, hey, Mamba Time, and he's like super happy, and I realize, you know, he sees the same people coming in every day buying these boring things, and yet I'm the one, like, I'm the weird one, I'm the one coming in buying these gummy bears, and he's like super happy about it. I'm like, hey, Mamba Time, so I'm totally making him happy, like coming in, making him happy. And I realized, like, why, I shouldn't feel awkward about this. I should just do it. Like, make this dude happy. I love these gummy bears. It's fine that I'm the weird one. I'm making him happy. So what I want all of you to do is I want you all to find your Mamba Time. And I want all of you to be the best Mamba timers you can be. So, all right, thank you. And I've tried to cram a lot of information into your heads in the last 50 minutes, so if you have any questions, please ask me now. If you want to ask me later privately, go ahead, and I have stickers. Yes?
So how does the active record objects not being thread safe interact with the caching of active record objects?
Okay, so the question was, how does the active record objects not being thread safe impact the caching of the active record objects? And the answer is, it does not impact it because even though when you execute that statement over and over again, we return to you the same data, it's still different objects. We store the internal state of the active record object, and then we dupe that and hand you a new instance. Yes?
You mentioned the internals being scary for a lot of things.
Yes.
How can one go about helping make it less scary? Because it seems to be getting scarier and scarier all the time. Okay,
so the question is, how can, okay, you mentioned that the internals are scary. How can we make it less and less scary? That's a hard question to answer. And the reason is because you have to dedicate a lot of time to it. I mean, it's difficult now, and you have to like look at it a lot in order to understand the internals. And so one thing, like, I'm on the Ruby core team and the Rails core team, and one thing that irritates me about being on the Rails core team is I feel like we move too quickly. Like, we're spending too much time looking at stuff like speeding up tests when we should be dealing with internals. For example, I showed you guys that I sped up Rake test, right? About 3 days ago, and actually it's still in master in Rails today, I actually need to go in and delete it. There's a thing called Rails test. We decided, well, speeding up tests is so important that we're actually just going to introduce a new command and completely deprecate all of the Rake tasks and be like, sorry guys, that's the wrong way to do it now. We're going to go in and change. We're going to give you a new test runner, and we're not going to bother to figure out why the freaking tests are slow. So I feel like there's too much of a culture of like, okay, add this feature and ship it, rather than like, let's just make the stuff internal look good or make it work well, easy to maintain. So that was a terrible answer. Sorry. Sometimes I get frustrated. So I think the best thing that you can do is pick something that you're interested in and really dive into it. Try to learn that as much as possible. My favorite thing to look at, my personal favorite thing to look at is database stuff, and I think that's because databases vary a lot less than somebody sending crap over HTTP. So the data that you get back from a database is a lot more regular than the stuff you'll be getting over HTTP. But pick something that you're really interested in and just really dive into that code. And the thing is, like, we accept pull requests that are refactors as well. I mean, we're not gonna, like, we don't just sit there and say like, oh no, you only have to add new features. Like refactoring code, absolutely. We take that for sure. Just start out small though. Start out small refactor and keep growing your refactors, and then pretty soon we'll give you commit and then you'll burn out. All right, next question. I think we have an hour. Yes?
Did you say that you're getting rid of queues in Rails 4?
Yes.
So the example you had about active records for reading and writing equipment, did you put them in queues?
Yeah, so okay, yes. Is that the question? Yeah. Okay, so the question was, you said you're getting rid of queues in Rails 4, but the example that you showed, you're putting your stuff into queues. Yes, that's completely true. So those queues that we took out of Rails 4, the point of those queues was to provide a standard API for queuing systems. So think of it as active record for queues, right? What we have at work, I mean, just because we took queues out of Rails doesn't mean you can't use queues. Like we use AMQP at work. We also use just in-memory queues. So these aren't queues that are specific to Rails. Any other questions? I think we have 4 minutes. We can end now. Yes?
So how about how the reaping of database connections interacts with the long-running connections for the event service and events and stuff like that?
Okay, so the question is, how does the reaper impact long-running responses, like database connections during long-running responses? It doesn't impact them. It doesn't impact it at all. We can actually ping the connection and test to see whether it's up without impacting the database connection itself. So we don't actually have to check to see. We don't actually have to check any data, send any data over the wire to check.
If the server doesn't have a new event to send for 30 seconds, so it hasn't used its database on that, is the reaper going to say, oh, that connection is stale, it's whacking?
So no, it's not going to do that. It just checks to see whether the connection is alive or not. So like if this is probably like a super duper edge case. If your thread dies and somehow the connection doesn't time out, if the database doesn't time out the connection too, then you could have a connection stay open forever. But otherwise, it'll leave the connection alone. Anything else? No, okay. I mentioned I have cat stickers if you want any. I know it's not super enterprise. All right, thank you.